Hi everyone. In the previous video, we discussed about the interpolation using trend line. Today, I'll explain the interpolation using various other functions in Excel. Let us take the same example which we have used last time, the relation between temperature and ice cream sales. We have functions in Excel to find out the slope and intercept without drawing the trend line. I'm going to get the slope here and intercept here. So to get the slope of this data, that is the relation between sales and temperature. So assuming that it's a linear variation, you can find out the slope of this relation between temperature and ice cream sales and intercept of that. So to find out the slope, you can use the slope function. So I'll type here equal to slope. Now to get the slope, you have to select the known y values and known x values. First you will select the known y values, that is the dependent variable, and then you have to select the known x values, that is independent variable. So after selecting that, you can close the bracket, press enter, you will get the slope. So this 576.54 is the slope, and you can get the intercept using the function intercept. So equal to intercept. So you can select the intercept function. Then again you have to select the known y values, comma, known x values. After selecting that, you can close the bracket and press enter. You will get the y-intercept. So this is the slope of the equation which you can form using this data, and this is the y-intercept of that. So the equation is of the form y is equal to mx plus c. So this is the form of equation. Y is equal to mx plus c. It's a linear relation you are finding out between the temperature and the sales. Y is the sales and x is the temperature and m is the slope and c is the y-intercept. Now you can interpolate the values in between other than the tabulated data. That is, in this example, the temperature is ranging from 14 to 34. Okay, overall 14 is the minimum temperature and 34 is the maximum temperature. So out of the various temperatures given, I have selected 3 temperatures within this range, which is not tabulated. So I'm going to get the interpolated values for that using this slope and intercept. So I'm going to use this equation y is equal to mx plus c. So here I'll type that equation equal to y is equal to m is this value. I am going to get 3 consecutive values. 3 values I am going to use the same m. When I apply the formula to these 3 cells, this value should not change. So for that, after selecting this, you can press function F4, function key F4, which will ensure that there is no relative reference. That value will remain same. So you can see that $sign on either side of E. So that means that value is going to be fixed when you apply the formula to the downward cells. So that is m value into x is, you can multiply by x value and temperature. Okay, that is in E14 plus you can select this value. This also should not change when you go down. So there should not be any relative reference. So I can again click F4 function key you can press so that it will also get fixed. So you can see again $sign on either side of F. So that fixes that. Okay. So you will get the value here. So this is the sales for a temperature of 16 degree. Now I can apply the formula downward by double clicking on the fill handle. So I'll apply the formula downward. You can see that E5 has remained constant and F5 is also constant, but only E15 instead of E14 here, it has become E15. But these things have not changed. Here also you can see that it is E5 and F5. So I interpolated the values using slope and intercept. Now again, there is a direct function in Excel. You can use a trend function to interpolate the values. So you can use trend. You can equal to trend. So select trend. Then again for trend, you need known y values and known x values. So here you need known y values. Known y values. So after selecting the y values, you can fix that by pressing F4 key. So I'll fix that, comma, known x values. Again, press the function key, F4 key, then comma. You have to select the new value of x. Here x is here 16, and that is in the cell I14. You can close the bracket and press enter. Here you are getting the sales same as this. Now I'll apply the formula here downward. So you are getting the same result using trend also. So trend is going to be a much easier function. We need not find out slope and intercept. You can directly get the interpolated values here. Similarly, you can do the forecast also. So there are two functions in Excel, forecast and forecast linear. In the latest version of Excel, instead of forecast, we have forecast linear, and this is used for predicting the data which are linearly related. So you cannot use this forecast and trend for exponential variation or polynomial variation. So you can use only for linear variation. So forecast I'll use equal to, you have to use forecast. You can select forecast linear. Forecast is also there, forecast and forecast linear, which will produce the same, but latest version you have forecast linear. So I'll take forecast linear. You have to first give the x value here. So that is x is here, x value in M14. Then you have to give known y values, known y values. Now to avoid the relative reference, you have to click F4, then again comma, known x values, again press F4 to avoid relative reference. Close the bracket and press enter. You are getting the same value, forecast linear also giving the same value. You can double click on the fill handle and get the remaining values for 19 degrees centigrade and 27 degrees centigrade. So you can see that all the three gave the same result. There is another function which is known as growth, and it is generally suited for exponential variation. This is almost linear variation, and for this it's not suited, but still I'll use the growth formula to predict this result. We'll see the variation. Equal to, you can type the function growth. You have to select known y, known x, and then new value of x. Known y's, press F4 to avoid a relative reference, comma, known x values, F4 you can press, then comma, x value, that is in Q14 cell, close the bracket and press enter. So you got 1845. So this is much higher than this value, and as I said, it's not suitable for linear variation. It is suitable for exponential variation. Anyway, I'll interpolate for the remaining values also. So it's giving much higher value in certain cases. Growth is suited for exponential variation, so it's not actually giving the reliable result in this case. Now let us use the same table to forecast some values. So I'm using the same table to forecast certain values. So I'll first forecast using the slope and intercept. So I'll get the slope in the same way. Slope I'm taking the known y values, comma, known x values I'll select, close the bracket, and I'm getting the slope, the same slope, okay, same value. Intercept, select the intercept, known y values, comma, known x values. I got the intercept. Now using slope and intercept, I'll find out the sales. This is forecasting. It's beyond the range. 34 is the highest temperature, so it is beyond that 34. That is future prediction we are making. That is forecasting. So it's outside the range of this temperature. So this you can call it as forecasting. To find out the sales, you can use equal to. I'm using y is equal to mx plus c formula. M is this slope. So slope I'll select, but I want to avoid the relative reference. I'll press F4 key into x is this temperature plus this intercepts. Again, to avoid the relative reference, I'll press F4 key, press enter. I got the sales corresponding to temperature 35. Now I'll apply the formula to the remaining cells. So these are the sales values corresponding to temperature 35, 37, 39. Now I'll use the trend to forecast these sales equal to trend. You can select trend, then known y values you should select. I should fix this, avoid the relative reference, press F4, then comma, known x values you can select, again F4 key you can press, comma, you can select the x value, that is 35, close the bracket, press enter. You are getting the same value using the slope and intercept. Now I'll apply the formula here down. Now forecast also you can use. I'll use forecast linear equal to forecast linear. I'll select, and then first you should select x, then comma, known y values. I should avoid the relative reference. Click F4, then comma, then known x values. Again press F4, close the bracket, and press enter. So I'm getting the same result here again. Apply the formula to the remaining three values. So you are getting the same result. So all these three, that is slope and intercept, trend function, and forecast linear, all produce the same result. Now let us see what the result growth gives. So equal to growth, select growth function. So you have to give known y values, press F4 key, and comma, known x values, press F4 key, comma, then you have to give the x value. So here 35, close the bracket and press enter. So you are getting 16,000, much higher. Now apply the formula to the remaining. So you can see that growth, it's an exponential variation, so it is producing much higher values than expected. So if it's a linear variation, you should get these values, but growth is not suitable for this linear variation of data. It is better suited for exponential variation. When the data varies exponentially, you can use a growth formula for forecasting. Otherwise, if it's a linear variation, it's better use trend, forecast linear, or slope and intercept to predict the future values. That's all. Thank you for watching.